So
10:01.
panning.
Great. All right. So welcome everyone. I was expecting a few more, but perhaps they will join in when they have a moment. Welcome. This is an interim virtual meeting presentation to summarize the work that's been done on the recycled asphalt pavement materials used in pavement preservation project sponsored by the Federal Highway Administration. This project focuses on material specification, storage, and testing. And so we'll get into each one of those topics in a few minutes as we move through the presentation. I first want to recognize Morgan Kessler, our project sponsor, for any introductory comments that he would like to make.
Yeah, thanks, Greg. Just wanted to welcome everybody and say thanks for taking the time. Like Greg said, this is a interim report where we're going to talk about how the project's gone so far and some interim findings and things like that. We're as Federal Highways, we're real excited about this project. It was on the heels of another RAP project that Greg did with applied pavement technology. And it's reflective of a lot of interest nationwide on the use of RAP in pavement preservation. So, this project specifically talks about specs and storage and testing and things like that. And, real excited to get that information out on the street. So, yeah, I was hoping there'd be a few more folks here too, but we'll go with what we got. Maybe some people will trickle in as we go along, but Greg, I'll hand it back to you and we could just get on into it.
Great. Thank you, Morgan. I want to provide just a little bit of time for folks to introduce themselves. We don't have a large crowd, so being able to say hello is a benefit here. I'll introduce the AppTech team first, or give them an opportunity to introduce themselves, and then we can go through our FHWA panel and adjunct members of the panel that are here, and then we'll introduce our SME team that's online as well. So I'm Greg Duncan. I'm the principal investigator for this project, and we have with us Arturo. How about you go first?
Hi, good morning, good afternoon, everybody. My name is Arturo Espinosa. I'm a engineer associate with Applied Pavement Technology. I'm working as a project engineer for this project, and I'll be the one handling the slides today. Nice to see everybody.
Thank you, Arturo. Abik.
Hi everyone. I am Abik Pothakur. I am also a project engineer in the project. I have been working with Greg and Arturo since last couple of months in the project, working specifically in the RAP availability determination and fractionation part of the whole project presentation that we're doing today. And then I'm looking forward to the webinar.
Katie is our host today. I don't know if you want to say hi, Katie. Maybe not. Okay.
Yes, I'm Katie Wieland, and I'll be facilitating the meeting.
Great. Thank you, Katie. Working behind the scenes is quite important, so we appreciate that. David Peshkin is currently vacationing in an undisclosed location in Southern Europe. So we'll wish David the best. He said he was unable to dial in today, so he sends regrets. Morgan, do you want to lead the FHWA team through introductions, or I can do that?
You bet. Yeah. I guess I can introduce myself. I'm Morgan Kessler. I'm the technical manager on this project, but I'm also a research engineer at Turner Fairbank, and one of the hats I wear is maintenance or infrastructure maintenance and preservation research. But let's introduce our federal highways folks here. First one I see on the list is Tony.
Hello, yes, Antonio Nieves from the Office of Infrastructure construction team, also involved heavily in preservation and maintenance. And when Greg said that David wasn't undisclosed location, the first thing that came to my mind was a CIA Black Ops site, but hopefully that's not the case.
Yeah. Hopefully
Not to my knowledge.
All right, Jason, see you on the list.
Yeah, hello, everybody. Jason Dietz, Federal Highway Resource Center, and just on this panel as a subject matter expert.
Thanks, Jason. Glad to have you. Then I see Tom Van. Want to introduce yourself, Tom?
Your voice is not coming in, Tom.
He is unmuted.
Right. Still not hearing you, Tom.
Maybe he was
These
having
Zoom
the same
widgets.
issue I had earlier.
Oh no.
Oh well.
Tom is also with the Office of Infrastructure. He's on the design and performance team. If he can get his audio working, that's fine, but that's about it.
Okay. Well, thank you.
Very good. Thank you, Antonio.
Yeah.
From our,
I'm sorry.
is that all?
Yeah, that's it for the federal highways folks that I'm seeing.
Okay, I had a few more accept the meeting, but they may not be on. I see an iPhone that's joined. I don't see a name with that. Are you from FHWA or one of our SME teams?
It's Mike Hemsley with Paragon Technical Services. Jack of all trades, master of none. So I know
Great,
everybody
Mike.
so far that's on the list. So
great. Thank you, Mike, for joining today. You are
yes,
a valued member of our SME project team, as well as our colleague, Don Matthews. Don, would you care to introduce yourself?
Yeah, I'm just trying to get my face real quick. Yeah, Don Matthews. I'm the Director of Engineering for Pavement Recycling Systems.
Great, Don. Thank you for being here. Both Don and Mike have been, we've been working them pretty good over the last few weeks, trying to get some specific information, backing up things that we've found and leading us to early findings, new conclusions, things like that. So been very important to the team, and we appreciate you being here. Is there anyone else on the meeting today that hasn't had an opportunity to introduce themselves? Very good, Arturo. So this is a slide deck that we put together just to brief folks on where we are. There's only about 20 slides, I think, so it's not exhaustive of the work that we've done, but it's we've added the key points for us to be able to talk about and share. I see Catherine Petros joining our meeting.
Hey, Catherine, would you like to introduce yourself? We just went through a round of introductions.
Oh, just in time, I guess. I'm sorry for being
Yeah.
late. It was in a different meeting. Catherine Petros, I lead the infrastructure analysis and construction team at Turner Fairbanks, FHWA.
Great, Catherine. Thanks for joining us today. All right. Arturo, if you want to go to the next slide, we've got our objectives of the project listed there. The first is providing a framework for determining when to use recycled materials for pavement preservation surface treatments. So this is one of the issues that we've been working, trying to figure out why agencies would make a decision to use RAP or why contractors would make a decision to use RAP, fleshing that out. We're also working on developing guidance for strategic RAP material storage. So we have quite a bit of work there to share today. The next is developing RAG processing and fractionation guidelines. Go ahead, Arturo. And so RAG is an abbreviation we coined in the last project, meaning RAP aggregates. Trying to shorten the items on the page a little bit. So we're not talking about those torn cloth items that were used to clean windows or our hands, perhaps, but these are those precious mineral aggregates that we're using for replacing virgin materials. So great. The next topic or the objective is to develop flexible, generic, and deployable performance-based treatment specifications. And this has proved to be quite difficult in looking at the information available. The performance-based piece of this is seems to be lagging in literature and what folks have found to be good performance-based treatment specifications. But this is developing a specification and test protocols for RAP materials in pavement preservation treatments is one of the products we anticipate delivering. So, and the last objective is recommending testing methods and frequencies within typical quality assurance programs that ensure we meet desired performance targets. So that's this is a list of the project objectives that we developed in our proposal, in addition to what was required in the RFP. So you see 5 bullets there. We talk specifically about 5 subtasks within the main task that was defined in the request for proposal. So next slide, Arturo. We're going to be looking here at the specific tasks that were required. Task 1 was to develop an amplified work plan and a work breakdown structure. We completed that task early on and delivered it with the next task, which was the kickoff meeting. And so those 2 tasks have been completed. We got the go-ahead from our panel to begin task 3, which is the assessment and scoping study. And that includes those 5 subtopics. So making the case for RAP, developing that framework, looking at storage, fractionation, specifications and a testing program are the 5 subparts of task 3. And it's where we've spent the last 5 months really digging into those topic areas and figuring out what the state of the practice is and where we need to go to reach our goals. Task 4 is today. That is the interim presentation and webinar to share with folks where we are with the project and to identify what we may be missing, or identify additional resources that we can tag to include into the work. Task 5 through 9 are all pending task 3 completion. So those are developing the draft report, developing a draft tech brief, and finalizing those. So those all fall into that category of, once we finish the research, we'll be able to deliver those drafts. Task 10 and 11 are ongoing. Those are our monthly project discussions and monthly reports. We are a little bit behind schedule. That's what our reports tell us right now, our work breakdown structure, but we have plans to bring those tasks into alignment with the overall project schedule. So that is ongoing. Task 13 to 15, we are in discussion about how to market and spread the word about how the project has gone. Those are data deliverables and SME task hours that are available to the project to do some things that were a little bit unanticipated, I think. So going forward, we're looking for places to market the efforts that we've made in this project, including the TRB meeting in January. We're also going to be having Tony present at the slurry workshop in January down in Las Vegas. And we'll be looking at pavement partnership meetings and state preservation meetings, things like that, to go and market the work that we've done, disseminating that technical transfer there. So very good. Next slide, please. So in this presentation is largely going to focus on task 3. And as we said, that identifying the scoping study basically is what it's called, but identifying all those parts and pieces that are moving out there there's so much information available and so many people to talk to. We're collectively moving through those in sort of a structured approach. It's really a 5-pronged fork right now, though, trying to capture the information on all 5 of those topics. We have done several interviews. Some of the notable ones, we worked with Max, who's a former FHWA employee. He's given us some guidance and talked about what his experience was in using RAP. And this really centers around that whole idea of what assists people in making a decision to use RAP in these projects. He helped set up some information gathering sessions with the FHWA headquarters office. So Jennifer Bayless was able to speak into how the FHWA office sees salvage value, surplus materials, that sort of thing, what the applicable requirements are. We also had Robert Ray from Nebraska. He's a DOT employee, but he had a presentation available that talked about the valuation of how RAP is viewed within Nebraska, what kind of incentives they now pay their contractors to use RAP in pavement preservation alternatives. So we're not seeing chip seals and slurries and micros there in Nebraska yet, but it gave us a perspective on what the value of that RAP material is. And again, I already mentioned Don Matthews and Mike Hemsley, part of our SME team, that they've been so gracious with their time and expertise, helping us see through some of the issues within the supply, processing, stockpiling, testing, and specifications area. So that's been awesome to talk to those experts and summarize what they told us. I didn't say this at the beginning, but this is intended to be sort of an open meeting. So if you have anything to say or questions, those can be asked, and we'll attempt an answer as we go along. So please don't hesitate to speak up there if you have something to say. Okay, Arturo, next slide, please. So when we think about that first subtopic, determining RAP availability is what we've called that, but it's really about making that decision. What promotes using RAP in pavement preservation treatments? The factors there, let's go ahead. Yeah. So factors impacting RAP availability include supply. Is there an abundance of RAP or a lack of RAP supply? So that impacts, the feasibility. And what we're not saying there as well is the supply of natural aggregates. Is there an abundance or a lack of virgin aggregate at a particular location? So if we look across the country, that abundance or scarcity exists at different levels. From the first project, we learned that aggregates are extremely scarce in New Mexico, for example. And we see scarcity across other geographical areas too, whereas in some areas of the Southeast, the Northeast, rock quarries are abundant. And so that leads us to our second issue there, is the stance that the agency takes. Is it an optional usage that the agency permits RAP to be used in these treatments in a certain percentage, or is it a mandatory use? And so that may be like Los Angeles County that said, we want to specify a RAP slurry material, and please provide that contractors. So that was a stance, whereas other treatments are, we have this RAP pile available, you can process it and use that material, but you are, as the contractor, you are required to meet material specifications, and you can use RAP if it meets the specs. So walking through the issues there and identifying the context of how specifications leverage RAP materials there. One of the things that we also talked about is who owns the RAP, and that isn't necessarily stated here, but that is an issue. And so as we think about agencies retaining RAP piles or RAP supplies, that may generate value for them. And so we talk about salvage credit on the next slide, but there are components of the valuation of RAP that have to do with what is the intrinsic value of those materials? And Don Matthews said it best, it's only worth what somebody would pay you for it if it were going to be used or sold. And so that value may be less than what value someone may see in that. Dr. Don Brock years ago had a good illustration that, you know, if wrap is 94% rock and 6% asphalt, then its replacement in hot mix asphalt would be 94% of the value of the rock that it's replacing and 6% the value of the asphalt that it's replacing. So that would be the intrinsic value of that material at one of its highest and best uses. And so if we think about that, the things that detract from that is what is the haul distance that material has to be carried from a point of milling into a point where it could be incorporated into hot mix asphalt. So we're also looking at the haul distance from the source there on the roadway to a staging area or a storage yard. So trying to identify what value is reduced from that wrap material based on that is important. We also see some agencies applying a sustainability value to the whole process. Just the idea that people are willing to pay a little bit more or recognize that there may be a premium in using some 100%, 80% recycled or reclaimed materials. We saw that in Los Angeles County. They market in a responsibility, from a responsibility standpoint, they provide sustainability information out to their constituencies. So trying to identify, is that worth $1 a ton or $2 a ton, $3 a ton, $10 a ton? Where does that fall from an offset standpoint that people are willing to take a stance that we're going to use more sustainable materials within their program? Storage is also a part of that value, and so identifying how much processing needs to happen in order to use the material and what that costs from a standpoint. So trying to understand how much storage is needed, where does storage come from, trying to understand all of those issues. I saved salvage credit for last because I saw this as one of the policy issues that we needed to discuss at the beginning of the project, and that has proven to be a complex issue, and we've been helped by some of our subject matter experts from FHWA in understanding what typical stances are and how that could be dealt with. And so next slide, please, Arturo. Yeah, so what we found is that there are a couple of different places where salvage credit is talked about. There's in the regulations, we found, like for instance, if equipment is required in a project, and that equipment has to be used for its intended purpose in that project, and if it reaches its useful life and it hasn't fully depreciated or been used up and it's disposed of or sold, that there is still some component of that material or equipment that is federally owned, and the agency that does that, the recipient of the federal funds, should be providing that credit. And so what we were advised is that the agency is taking a look at how agencies receive those funds, and the 2 CFR 200-313 talks about state procedures and using state procurement procedures as a way to handle those federal funds. And so what we described in talking about, if RAP is milled from a federal aid highway and taken to some storage location, what is the salvage credit that would be due the FHWA from that? And so we talked about ways around that money wouldn't have to necessarily change hands, but if there were state procedures that said this RAP material is going to be used in other federal aid programs like pavement preservation, then that could be an acceptable use of that material. And so we were encouraged to take a look at defining what state procedures might cover. And so we used the CFR guidance to walk through that, and the discussion was, how will the RAP be used? So establishing a program that says this amount of RAP material will be taken from a certain project, and it'll be stored at this location, and it will be used, processed, fractionated, protected, prevented from loss, other things like that, and it will be used on other projects as aligned here in this district. So just laying out those specifics that RAP will be used for another intended purpose, where it will be used, if that information is available, or our understanding is that it could be used in a program of projects that could be defined later, that the inventory should be maintained, that records would indicate how much material was received, how much then left the yard or left the pile and was used as a component. And I have to say that this is all assuming that the agency retains the material on one of their sites, that it does not become property of the contractor at the conclusion of that first milling operation. So this is a different stance than what a lot of states have adopted. So, and there has to be quality assurance. One of the Jennifer identified, if the material becomes contaminated, that is I'm not sure that the FHWA would participate in cleaning that up. There's a certain amount of stewardship that goes along with maintaining that material in a quality form that can be reused. So one of the quotes that we have that came from Iowa in this regard is that the FHWA requires the salvaged material removed using federal participation removal item, such as milling, and must be used on projects eligible for federal aid funds. We will assume this will be the case unless we have knowledge to the contrary. If the salvage material will not be reused on a project eligible for federal aid, the FHWA will be reimbursed for the salvage value of the material. So I think that pretty well describes the idea that if FHWA participates in removing material from a project, and the agency keeps that material or salvages that material, that that is an acceptable use so long as that material goes back into federal aid eligible projects. So I anticipate lots of back and forth with folks as we try to work through the verbiage here and describing how those state plans might be used. So any comments or questions there? Tony, I know this is sort of in your organizational structure, and you were in attendance at that meeting. I don't know if you care to elaborate.
No, Greg, you're spot on, and I think the operative word is where they're storing the wrap. Who is the custodian of the wrap? It's almost like a criminal case when you're talking about evidence. It's the same thing, the chain of custody of the material. If it has been allocated to a state storage site, it's very different than, I guess, a contractor site. So that becomes kind of a sticking point. But one of the things that might come from all this is whether the states are willing and able and wanting to have storage locations available for the wrap. I don't know if they do, if they want. I mean, you talked about the sustainability factor in all of this issue, and if they are stewards of sustainability, it becomes a point where not if they do, but they have to, and then that would be, I guess, another element of their operations that they'll have to take into account. That's basically, in a nutshell, what may or not happen, and that will be a decision on the side of the state DOTs on what they want to do.
That's right. That's right. And what we're hoping is to provide guidance that will help them walk through those decisions and put pen to paper and estimate costs and that sort of thing for how does that look? Is it worthwhile to keep a wrap stockpile themselves, or does a market become available like within Southern California where wrap is available commercially and people have access to use that on projects. So
Greg, I do have a question for you. When you were talking about the position that California took in terms of sustainability, when they're doing their accounting of the use of wrap, are they looking at more from the aspect of being carbon neutral, or are they looking more along the lines of what they would calculate or estimate would be what their global warming potential is? How are they factoring that sustainability part?
So currently what I have seen is they are looking at, and Don, you may supplement this information when I spill my guts. What I've seen is they said we reuse this amount of material, and we eliminated this much material from having to be harvested from virgin sites, and they make an estimation of how much greenhouse gas they reduced in their preservation processes. So I don't know if they're considering that versus virgin aggregate, or if they're considering that within their total preservation program, that we eliminated so much rehab or reconstruction by using good preservation practices. Donna, welcome what you have to say about the information you're hearing from.
Right now, there's not a hard and fast program across it. A lot of agencies are looking at it. Some agencies do look at it with respect to one, just their technique that a comparison of the techniques that they were going to use from a design project standpoint. And pavement preservation, by preserving early, does a natural greenhouse gas savings and everything else. And then when they're looking at projects, they typically look at the amount of aggregates, virgin aggregates that were replaced, and the credits, or I don't want to use the term credits, but the carbon impact those have on there. I know some agencies look at this pretty religiously. You know, County of Los Angeles does. Caltrans right now, I don't know how they're doing it, but they're definitely looking at EPDs and that type of thing, and with respect to each process and trying to implement that.
Does that answer your question, Tony? I know you bounced out and back in.
Yeah, it's I think it's a growing concern, I guess, that they'll have to grow into and see how they're going to essentially look at how bringing RAP does contribute to their sustainability efforts. And I think it's still further ground, and probably a lot more thinking and discussion will have to go around it. But it would be nice to keep up with what Caltrans is thinking about, because we as a federal agency can help explain a little bit better to other states what other states are considering when they're using RAP. So I mean, say it this way, to be continued.
No, I agree with you that this is a rapidly evolving state of the practice for calculating environmental, what are they called, the EPD, environmental product declarations, I guess is the terminology, and EMA, ERA are involved in this conversation as well. And I know that the sustainability efforts within FHWA are looking at this as well, and even FAA is trying to figure out how to reconcile RAP use and quantify its life cycle benefits and environmental benefits. So rapidly evolving discussion. Anyone else care to weigh in there? I think we've got time.
Oh, yeah, you know, Greg, I've been interested in this topic since it came up, you know, last year. But sounds like between your input from Max and others, sounds like we have some good guidance on how to handle this topic. That, you know, right when we first started talking about it was, I guess I had heard about salvage credit, maybe with other materials and stuff, but this idea that it still has some value and maybe that value has to be paid back to the agency, that, I don't know, that just didn't sit right with me. So you guys have done a good job of kind of vetting this topic out, and we appreciate it, and it'll be good when it winds up in our final document.
Great. Very good. Thank you, Morgan. Anyone else? All right, let's move into RAP storage. Arturo, this is we came up with this graphic to sort of illustrate how people may be storing RAP once it once it finds its way onto a storage yard. And so we've defined, or we're using two terms that existed there as an unclassified wrap pile, which may also be considered a God only knows pile, I've heard it called by some, versus classified wrap piles, which are very discrete project location kind of piles, so that every project that gets milled or collected comes onto the yard and is kept in a discrete location, not mixed with other projects. And so the way we've described that is go ahead and hover your pointer there over the individual piles. You'll see if your screen is big enough, hopefully you see that the unclassified pile has a blend of aggregate textures in it from locations. But if we look at the classified piles, each one of those has an individual texture of its own. And so the process is that the materials come onto the yard, they're discrete, they're processed, they're evaluated, tested, and then moved into projects in that discrete manner. So the materials are never really blended with other materials, and we would expect to see those discrete piles used in discrete projects, and we would have a really good handle on what those material properties are. The other way that materials are used, and I don't want to imply that there's less quality in that, but it's less is known about the origin of the materials as they're piled there. And so we're thinking about quality control, testing, those kinds of things that have to happen with storage materials that, the idea with that unclassified pile is that that's made up from a lot of different projects, and testing frequencies may be more stringent or more frequent because we really want to maintain a consistent product through processing, understanding what materials are there, what their properties are, and then as we use those, that would be usage made up of the conglomerate materials. So a blend of materials there, and I thought it was cute that I could use a peace sign in a professional presentation there, sort of. So maybe I'm making it less professional, I don't know. But the idea that those materials come from a lot of different sources and get used in an aggregation is what we're trying to convey there. So we're going to talk about processing and analysis specifically, but we are looking for practical experience about storage. There's an idea that materials need to be processed and used quickly after processing. So there's multiple storage kinds of ideas there. We have the initial storage in which you worry about the materials becoming contaminated or something like that, but we're not really seeing significant changing of material properties at that location or in that phase. But once we process them and get a good idea of what we have there, we want to use the materials pretty quickly, especially for chip seals and microsurfacing. You want to be able to process them and handle those materials in the construction sequence without them re-agglomerating. So because we're using an asphalt coated rock, typically we're worried about what's the temperature, what's the humidity, what's the likelihood that those materials adhere to each other. My recollection from our interview is that you want to be using those materials within just a few days of being processed, so that risk doesn't happen. From an equipment standpoint, we may need to have reprocessing equipment available at the satellite storage locations if materials are processed and then carried to a central site where we might feed a chip spreader from, or a chip seal operation in that regard. We may need to have additional processing there. The same is true for the fine aggregate materials that would be used in slurry systems. So any questions about storage here? We've done a little bit of work looking at typical pile size and how much can be stored on locations. We'll move into part of that discussion next if there's nothing else. Okay, next slide, please, Arturo. So this is an example of what we'll be presenting in our final documents. We've gone out and done some Google Earth analysis of looking at where storage yards exist. Don was kind enough to point us to one of their main lots and look at how much material can be confined there. What we see at a typical plant location is that there may be, a total of 21 acres involved in setting up an asphalt plant and having material storage there, with about 6 to 8 acres used for their various wrap piles. So we see some unclassified wrap piles. We also see some discrete project type wrap piles confined on storage yards. To contrast this, 20 total acres, I went back and measured the location in Grants, New Mexico, where Lisa Vega had storage for our previous project, and that was at a interstate interchange location. They had some property along the exit ramp, and they were able to use just an acre of property to store and process their wrap pile, and they fed 3 to 4 pavement preservation projects out of that lot. So that's the kind of scale of information that we're looking for to help agencies understand, how much storage do I need? So to Tony's point, as people consider how much is this going to take up of my property and what are the impacts there, we're seeing anything from an acre, all the way to a 20-acre contractor lot that is processing wrap materials. So any questions? Next slide, please, Arturo. So when we talk about processing, I use that term to discuss the fractionation process that really has to happen to make wrap useful in pavement preservation treatments. Because we're looking at chip seals and slurry systems primarily, we're thinking about how does fractionation happen, and what are the factors there that affect efficiency, production, the space required to do that. And so we're largely finding that there are brochures of equipment, and people are trying to sell fractionation equipment, but there are not many studies about how that material gets used, processed, and what are the practical findings from that. So again, we've relied on our SMEs to give us a little bit of information about what we need to consider and advise agencies when fractionation is a need or a requirement. We've reached out to 2 equipment manufacturers. I have responses from Aztec Industries. They have expressed a willingness to participate with us, but we haven't been able to meet with them yet. So we've proposed some dates over the next couple of weeks when hopefully that can happen. We've identified Chad, based in Illinois, with Aztec Industries, that's helping us pull a group together. We're not as far along with PowerScreen, but both of these entities provide portable screening units that can be set up on projects. And an example of that is Viasun, who was contracted by the city of Phoenix to fractionate materials for their use in slurry systems. So we'll be using them as additional sources of information for what their production rate was, how much labor was required to feed that fractionation unit, how easily was it to set up and keep operational, that sort of thing. So those are the things we're trying to pull from our SME group. Next slide, please, Arturo. The factors that we see in fractionation is how much material handling is required. It's you typically see a front end loader feeding the fractionation unit, and then the material gets stored incrementally and then used in the processes. So how much material handling cost is there to keep the fractionation unit operating? Basically, when fractionation is happening, there is a crushing unit installed at the beginning to help break up any conglomerates of the wrap material, and that any oversized material gets funneled through a bypass screen into a recirculation process, so that oversized material makes its way back to a crusher. Now, we've been advised that crushing wrap to make smaller particles is not really desirable. You want to just use an impact crusher rather than another kind of cone crusher or that sort of equipment that really makes the top size particles smaller. You don't really want to do that. You just want to break up the agglomerations within the wrap and then separate the materials as in different sizes. And so that's the illustration there, that a lot of material goes into the core screen. That material is separated, and coarser material may be separated from fine material. And that's typically what's happening. We're seeing the material separated into 2 sizes. The chips are used typically for a chip seal application, and the fines are used for a slurry system, ideally, or they're fed into an asphalt plant, or used as another type of bedding material or shouldering material, something like that. So the issues with conglomeration, that is why we see crushing equipment installed at the beginning of the screen decks. There is a we're looking for efficiency when we talk to the manufacturers. What is what is the oversize that makes it down the screen and should probably fall through? So looking at a flat screen, which is more efficient than a slanted screen, what happens with rescreening and that sort of thing. So trying to talk through the issues that manufacturers see with clients. We're also trying to talk through the practical issues of people operating the equipment in order to get the products that they need to make their preservation treatments. Next slide, please. Additionally, we're looking at, are these mobile or stationary? What are the production rates, assembly times? How many decks, screen decks do they have? What are the available sizes? If we're looking for a 3/8 top size fine aggregate, or a 5/16 or a 1/4 inch, that could potentially have different deck sizes that work that material. And that would yield a different percentage of coarse aggregate versus fine aggregate. Looking at how those fractionation units process materials there. So what's the transport requirement, and what are the limitations of the equipment? What will they not do well? Next slide, please. All right. So a lot of our recent efforts have gone into looking at the testing requirements for wrap use in pavement preservation treatments. And we walked through trying to list all of the tests that are currently required in design and construction specifications. So we have a list there from ISSA and also from AASHTO and ASTM that sort of build into the system of designing these treatments. And so you see a lot of the ISSA mixture requirements, and so they define how the treatments get designed and what the performance requirements of those treatments particularly should be in these tests. So we really wanted to understand from a material standpoint, looking at aggregates, emulsions, and then the mixtures, how does wrap need to be considered in this paradigm? So there are felt like hundreds of tests that we talked about. We had to reconvene with Mike and have a second hour-and-a-half session talking about all these D's and T's and all the numbers that were available. Some of the reference materials were out of print even, so trying to understand what the tests required and where wrap would really make a difference, because wrap is an asphalt coated aggregate. And so some of these tests aren't as applicable as they are to virgin materials. So we walked through that. The next slide gives us a little bit of a hint into where modifications are required. And so these are the things that you'll see called out in our final report. There will likely be some additional areas that are mentioned, but these are the key areas where we thought wrap was going to make a difference. And so some of the considerations, like for gradation, for instance, that aggregate gradation, T27 is the AASHTO reference for that test. And we need to understand that wrap material both in an unextracted form and in an extracted form. So the recommendations that we're hearing from practitioners is that the ISSA gradation guidelines for slurry and micro specifically are really important to how that material performs. And so we want to see those extracted aggregates comply with either a type 1, type 2, or type 3 treatment gradation. But what we see from a quality control, quality assurance standpoint is probably going to be that unextracted wrap. That's going to be the quick and easy quality control process that contractors and agencies are using to keep a control or to verify control on their materials. And because it's an asphalt coated rock and it's sticky, there are fine materials that are adhered to the coarser sand size particles, perhaps. So we're going to see less dust in an unextracted wrap sample than we will see in an extracted wrap sample. So that may be intuitive for you in material terms, but that's what we're trying to quantify there. There are also some changes to the bulk density requirements, so that's part of the design process that has to be completed. So you're seeing there for a chip seal run, bulk density test as an asphalt coated aggregate. That helps you understand what your drop rate is for chip seal, what the calibrated drop rate should be, and for the slurry system design, you need to run that test in water on the asphalt coated fine aggregate. There was some speculation about what needs to happen differently with emulsion testing, but largely we are applying virgin emulsion to all of these treatments. We're just doing it in slightly different quantities than we would be doing for virgin materials. And so all the tests that apply to the emulsions, sampling and testing requirements are all the same for those materials. The caveat there, as Mike Hemsley pointed out to us, is we may see some slightly different chemistry used in emulsions that are going to be applied with wrap, but it's the agency specifying it would never see any differences in test results because of that. That's something that the aggregate supplier and the emulsion supplier and the contractor have to understand and work out. But the material properties of the emulsions is our understanding that those would, a test result would always be meeting that specification, even if the chemistry is slightly different. And the reason that chemistry has to be slightly different is because the asphalt coating on the aggregate makes the aggregate less reactive. And so that's one of the things that we know about emulsions is that they break and set up over time, and that time to set up is a little bit slower because of the wrap materials. So that has to be a chemical consideration there. Did I say that right, Mike? Hopefully I did.
Hey, Greg.
Yes.
Go
ahead, Jason.
Just go ahead. Okay. I just wanted to, I'm not sure if you knew or not, but NCAD has got a wrap mix design research effort going on. And last week when I was out in Panama, Pennsylvania, they gave a presentation, and they're breaking up their mix designs like different levels, like a basic, medium, and high levels. And then with each one of these design methods for the wrap, they'll encourage more inclusive design principles for like a step 3. You may do it more specifically type of mixed designs and things like that. But I just FYI.
Okay. Are those for pavement preservation treatments or for hot mix?
No, they're for pavement preservation treatments.
Okay. I had not heard about their research efforts there.
It's
So thank you.
something, and I could forward to some information. It's something that they did from the Midwestern Pavement Preservation Partnership Group, wanted them to do for them.
Okay. And that's being done by NCAT?
Yeah, it actually, my apology. It's from that Minnesota cooperative effort. I can't remember the name of it's called.
Roads, yeah, the
Not
NCAT
Roads,
Roads.
but it's the other one. That research group that they have that they look at a variety of different preservation issues.
Yeah,
NRRA.
Yeah, that's it. That's
Yeah.
it, Greg.
It's
They
a
chose
consortium.
this. They chose this study, and that's what they're doing for NCAT. And I could forward you more further information.
That would be great. I would appreciate that. I can tell you that there's also interest in what we're doing here from ISSA. There was discussion. I attended a forum a couple of weeks ago, and there was discussion about how RAP is being treated and looked at. And so there's interest there to see what we summarize, and then that may be incorporated into other technical bulletins, or there may be some guidance that come from that industry group on how to incorporate RAP into these treatments. So that's encouraging and exciting from my standpoint. That could lead directly to implementation efforts. Very good. So to Jason's point, what's different about the mixed designs when we look at including RAP in the mixtures list of tests there, with some of the topics highlighted, that compatibility by Schulz Brewer Ruck procedure, that is an issue where that test requires a specific amount of material to be mixed into the sample, and the RAP carries a little bit more asphalt in there, but the recommendation is to stay with that amount, that 8.125 residual asphalt content added into the sample. And so that's a torture test to determine how well the asphalt and aggregate like each other, how well they stick together, and what the durability of that process is. So that will be described. The measurement of stability, low cohesion could be an indication of an over asphalted mix. So that's something we worried about when we're putting in aggregate with RAP already on it. And if you remember from the first project, we're typically seeing in slurry systems, we're seeing 1 to 2% less asphalt emulsion going into the excuse me. I don't know if I'm going to be able to talk. Excuse me just a second. Okay. Let's see if I can continue now. All right. So, I think I want to go to the next slide.
Yeah. Yeah, Greg, I think as part of the discussion, I think one main takeaway was that RAP for these preservation treatments was mostly considered as, as an aggregate source rather than expecting to get some binder out of it. But from our discussions, and the last point that you made will be that there is some consideration to be taken if you start to see that some of these tests are not passing, in the sense that they could be an indication that some of that recycled asphalt is contributing to your total asphalt content, and thus making it less stable, less cohesive, etc. But in general, we're looking at RAP being more of a aggregate source than a binder source.
Absolutely. Thank you, Arturo. And that's where our RAG abbreviation came from, looking at the RAP aggregate material contributions. Good. So let's go on to the next slide. So part of the RFP asked us to look at performance-based specifications. And honestly, we've taken the approach, there aren't many of these available out there in the world right now. There's some texture tests and things like that that are happening, that are being studied, and there's just not many in practice right now, looking at slurry systems, chip seals, those sorts of things. We have found a warranty specification for chip seals that, we were hoping, well, maybe that how objective can that be? But it's really a visual test or a visual observation that's made about 6 months after the material goes down, and there are some photos and comparisons. If it looks like this was the issue, and here is the culpability of the contractor for that kind of repair. And so we're looking at that in light of how objective or subjective is that, how likely is that to apply in other locations, and how widespread is that used in the agency. The state agency that's doing that is the Idaho Transportation Department. So that's one source that we found that we thought was on the performance-based or performance-related specification end of the topic. When we looked at slurries and micros, what we really saw were those torture tests that are used during mixed design. And so the slurry tests, abrasion loss, that's also called the wet track abrasion test.
Yeah, I'm sorry. I misclicked on what Jason was sending on the chat. 1 second.
Yeah, that's okay.
All right, there we go.
Thank you. Thank you. The excess asphalt test, the wet stripping test, the cohesion test, those all have some form of torture in them. Condition samples get tested in various ways. The microsurfacing, which is a beefed up slurry seal, basically has all those design tests plus the loaded wheel test and the Schulz-Brouwer and Rutt procedure that's run on them as additional conditioning and torture testing. Those are about the best thing that we're coming up with from a performance-based standpoint as to identifying what's the likelihood that these are gonna work. And again, so many of these performance issues turn out to be workmanship oriented or application oriented. You know, I've never hidden my desire to have tack used in these slurry treatments. Most of the time, that's not an applicator's opinion, but that's from my state specification days. That was what we wanted to see to get a good bond and good performance out of those materials. So we did see the Los Angeles County have a field produced mix required to be used for abrasion loss measurements, the wet track abrasion test. Again, there are some slight modifications that have to be made to that test using a thicker sample and a different kind of mold when you're using field produced material. So that's a consideration. Some agencies also require rolling shortly after construction, so that needs to be taken into account during the test procedure itself. And what we're finding is that specifications and tests largely fit together. So that will, whereas they're different components of our 5-pronged approach to digging into task 3, they're largely related. That when we have specifications, they're largely based on test methods, and that's likely how we will be reporting out on those. So look for combined information when we present specifications. Finally, the chip seals. Part of the design component there is just compatibility check. Are our aggregate components going to stick well to our emulsions? And so there's a sweep test to help define what the likelihood of having chip loss or compatibility issues with those materials. So unfortunately, that is a lacking area that we will not be. It doesn't look like we'll be finding many performance-based specifications for these treatments. Perhaps that project that Jason mentioned will be producing some more information that could be incorporated here, but that we're not aware of that at this time. If we look at hot mix materials, which was included in our project, we largely see the AASHTO M323 procedure, which most states are incorporating into their specifications, that require wrap mixtures to be run through design equations. So if we're using wrap above about 20% in the mixtures, the test procedure says you have to recover the binder from that aggregate and then do some tests. And Mike has talked about there may be some applicability to that kind of process for understanding micro mix designs and things like that, using some recovered asphalt to run a penetration, or the sharp binder tests. That's not in guidance right now, but looking at what the stiffness of that material is and understanding if it in fact does contribute to the mixture properties like it does in hot mix asphalt. So This is part of that performance paradigm that if you're using more wrap, perhaps you need to incorporate a softer base asphalt into the mixture. The procedure, one of the things that I looked at is how do they determine the aggregate specific gravity? So that is included in that specification as well. And then the idea of how do we blend the asphalt cements together in different percentages, what kind of end result binder grading does that give us, and does it meet the binder grading of the material that the agency specified? So most state agencies also require quality control plans that govern the tests that are performed on the wrap materials and the frequency. So next slide, please. So that takes us to a summary of our early findings, and hopefully these are familiar to you. Catherine, I see a link you placed in the chat, but I haven't. Maybe Arturo can speak to whether that's been explored or not. The early findings, I've touched on those already, that the wrap availability seems to key on how do agencies look at the value of that material that they have coming off projects, and is it worthwhile for them to stockpile it someplace and give pavement preservation contractors access to it? Because in many places where there's not a commercially available wrap source, asphalt plants, asphalt companies typically are not willing to sell that material, especially to vendors that they deem unfriendly to their industry. So how do agencies say yes to using wrap? That is the salvage value there is a critical piece of that. From a storage standpoint, you want to reduce long-term storage of processed materials. So once it makes its way through the fractionation equipment, you want to use it almost immediately. The fractionation equipment needs to be configured to maximize the wrap output and limit production issues. So make it easy to feed, easy to haul out, and hopefully that material can be processed very quickly or not processed quickly, but make its way to a project to be used fairly quickly without requiring reprocessing. From a testing and specification standpoint, Arturo spoke to this just a minute ago, that wrap functions as a coated aggregate in most cases, with very limited contribution of the asphalt liquid to the aggregate. Go ahead and advance that next. Yeah. And there are some tests that are standard tests for pavement preservation that will need some caveats, some delineation, and some explanation for how they would function with wrap being used there. So, all right. Any questions about the project presentation as a whole? I know we've dealt with some of those as we've stepped into it.
But Tony's got a question.
Yeah, Greg, when you said that you have to fractionate immediately, that is for project purposes, right? The question that I think I'm a little bit confused on, you can what's the length of storage, if there is any, of that pile? Can you have it several years stockpile, but when the fractionation needs to happen is actually immediately upon its potential use on a project? I guess that's what I'm kind of a little bit confused.
Yes, you surmise that consistent with what our understanding is, that the long-term storage of the conglomerate materials can, there's so long as the material doesn't get contaminated, we don't see a limit in how long the material can be stored. And Don or other SMEs may speak to that, but it has to be used within just a few days after it gets processed, or else you run the risk of having to reprocess it before it gets loaded into trucks and used for the specific treatment.
So Greg, maybe I could elaborate a little bit on that.
Sure.
So we process, there's a difference between the slurry dust and the wrap chip. So when you process the finished products and you do wrap chip, that can store for quite a bit of time because there's, a lot of air voids and it breaks up very easy. When you do the slurry dust, it kind of depends on the temperature. If it's cooler weather, you could have a couple of weeks before it starts getting harder in the bottom of the pile. If it's summertime, yeah, you want to process it and then use it in a few days. But when we say reprocess it, it's not like you're crushing and screening again. All you're doing it is typically run it through the screen right again real quick right before you load it out, just to break up any little conglomeration. They're not really hard, but they're hard enough to get stuck in the machine. I hope that answers that question.
That's great. And I do have a follow-up question, because it seems that the operative word in the stockpile storage is contamination. The question here is that we would probably have to come up with some sort of guidelines for people when it concerning what contamination might be and how to maybe avoid it, I guess, is something that needs to be addressed eventually.
Yeah. So there's kind of two issues. It's one, the material you bring in, before processing, and then it's contamination after. Really, the only issue that you get after you've processed and you got a good clean pile on there is, other than if you're near an area of, a lot of sand around you and you get sand, really high winds, and it coats the edges on the sand, you may have to scrape it off. But other than that, you really don't have a problem with contamination on your final processes. By far, the biggest issue you have is the material going into the processes, into the products you build on it. You want to make sure, Greg did a really nice job of showing it. If it's all good, clean wrap and the source, you want to keep all that together. If you get kind of removals and that type of thing, you probably want to keep that out of your good wrap pile and put that in another wrap pile that you do further evaluation on it. In all cases, you want to make sure you're not getting any mixed dirt in there or anything else on there, or any other trash in your piles. So I hope that answered your question.
Very good. Thank you, Don. Yes. So any other questions from anyone?
I've got a question. Maybe we could just kind of wrap it into part of this panelist thing you got going here, Greg. But and forgive me if I'm asking the wrong question. I mean, I'm not really a testing guy per se, although I'm familiar with a lot of the hot mix tests especially. But so is there anything that you guys found in your study that could be construed by an agency or an agency's testing outfit, their lab or whatever, as a barrier to using RAP from quality control and testing perspective? I mean, it looked like all the tests that you referenced were pretty common tests. Is that true? And is there kind of any piece of it that somebody could hold up to maybe a agency wanting to implement a RAP and preservation program and say, hey, well, we just can't test this part of it or something? And again, I'm sorry if I'm asking the wrong question, but hopefully you get the gist of what I'm trying to get at.
Sure, I think that's a good question, Morgan. The criticism that I've heard is that using RAP in pavement preservation is not the highest and best use of the material, and we shouldn't necessarily look to do that. And there's a lot of cost factors and valuation factors that go into deciding to use RAP. Doug Ford, who's one of Don's colleagues there, in the first project, said, the thing that I have to convince clients of is this is not a dirty rock. This is a high quality rock with some asphalt and some little dust particles and smaller aggregate sizes adhered to it, and it still works in a lot of applications like a high quality aggregate and not a dirty aggregate that you would typically see with coming along with some of the deterioration or chip loss or poor adhesion, those sorts of things for chip seals and slurry systems. I would welcome other points of view, though. That's what came to mind hearing your question.
Yeah, thanks.
Yeah, I get my 2 cents will be that it goes back to that point that we made about using the RAP as a rock aggregate or as an aggregate source rather than getting some binder replacements. So to build on Greg's point, binder being the most expensive component of like an HMA. Some contractors might see more value in using it on those type of applications and getting some binder replacement, basically reducing their demand for fresh binder than just expecting to use it as a rock. But again, it will be this will go back to one of the initial points about trying to gauge the demand that contractors will have in the area, let's say like the next season or the next year, and counterbalance that based on whatever RAP they have at hand, or if they're going to be able to procure it or buy it from another source, whether that's another contractor or something like that. But yeah, it seems like the economics might be the most pressing factor to deciding on whether or not they will like to use it in preservation or regular HMA. From the testing standpoint, I don't think there might be some small technical challenges on maybe doing the actual test and stuff and interpreting the results, but not something that, oh, this test is completely not applicable if you use RAP.
Mm-hmm.
So my understanding, Mike, I would welcome your opinion here, but in our discussions, you know, you led us through where RAP would require little tweaks to the testing procedures and things like that, and it seemed like the most significant factor would be having to extract or use a furnace on the wrap to measure a true gradation of the material periodically. So that may be an addendum to the testing requirements for a typical pavement preservation project.
I would also consider, you know, the gradations as you're running them are definitely, or I should say, the gradations as they are coming through the material as once they've been processed are definitely, you know, one of the things that you need to have a good control on. So, you know, as I termed it, and he said we can't use that specific term, the black rock gradation or the black washed gradation. You know, that's one thing, but understanding how that material is agglomerated is another thing, right? So you want to make sure you know how those agglomerations are formed or distributed through the gradation. Because some of those agglomerations won't break apart. You know, they are indeed a black rock. But I think specifically one of the things that we're interested in, especially in the mixed design procedure, once you see, you know, like you mentioned, we're paying particular attention to the tests as they are going through the process, and how it's different than just a virgin aggregate would be, you know, when you see the test results. And, you know, benefit about being in the lab and not just looking at data is you can also get a feeling for the samples as you're seeing them being run, and how they look, and, you know, their appearance along with the data results. It kind of helps you understand better what you're putting together. And if you see questionable data or questionable performance, you're more so able to then make the decision, or if you need to, maybe you did it on the front end. We typically will run a burn, an ignition oven, get our asphalt content from that, and then run the washed gradation, or extracted gradation, or however you want to call it. But if we see problems through the design process, we will go back and run an extraction and then recover the binder. Not so much so we can evaluate the aggregate again, because we already have a pretty good capture of that, but then we'll take that recovered binder out of the solvent and hand it off to our binder group so we get a better understanding of, and you mentioned this earlier as well, the penetration viscosity characteristics of that asphalt. So we understand better what the life expectancy was in that asphalt. So recently I did a mixed design. It was, we were using wrap. We segregated all the materials out. We were recombining everything to make some chip seal chips, and then use the remaining material as a slurry seal gradation. Everything went fine. We were interested in trying to maximize the amount of chip seal aggregate that we could get out of it. So we did a type 2 for the slurry seal gradation. In that, we found that it did fine all the way through the tests, except for the multi-layer loaded wheel, which was TB 147. So we went back through, we weren't expecting that. We went back through and we saw that the asphalt was even though it broke down, we had to crush it. So it broke down through that crushing like we would have expected it to for a harder pin asphalt. The pin was right there on the borderline of where I would have called, said that we would have seen insignificant effects from it, but it was right there on that borderline. So it was in that high range. And as a type 2, we had issues with it. So we had to take some of the chips away from the chip seal program and put it back into the gradation for the slurry seal program to make a type 3. And that was when the multi-layer loaded wheel portion of that testing, we didn't have issues with it anymore. So we had to get some structure back into it. And that was because our penetration was right there on the verge of, and this is just an internal guidance that we use, but it was right there on the edge of what we considered, or what I'll say is insignificant effects. So that's the kind of thing that you have to be careful of through these design procedures, and that's where looking at your pin and viscosity and developing the relationship based on the area of the country, it helps you be mindful of number one, the asphalt content, the virgin asphalt that you're putting into the mix, and then your overall asphalt content, and then also your gradation that you're trying to use. So thankfully we were given that luxury that we could move to a type 3 in that instance. But those are the kind of things you have to be on the lookout for during the design of materials using wrap and pavement preservation. So did that pretty much cover what you wanted me to, Greg?
Yeah, I mean, that what you said there at the end, that optimizing the gradation that you can pull out for a chip versus the performance that the fine aggregate portion is going to have. I think that's an important consideration that agencies will have to figure out, and that may change the screen size that has to be used to process the different fractions. Where is the split happening?
Right. Now, I mean, we could have gone material wise, maybe our emulsion, we could have used a harder binder. We could have probably been able to bring our emulsion content down. I mean, there were several things that we could do to make that change, but none of them could get me past the little bit of instability that we were seeing with that mix because of the overall asphalt content. So I wanted to effectively bring that asphalt content down, but I also wanted to put some structure back into that mix. And that's where the extra, the coarser material coming from the type 3 aggregate gradation gave me versus the type 2 gradation.
Gotcha. Don, it would be interesting. I know you guys do your own mix designs there. Are those considerations consistent with what you have to do if your clients are specifying a slurry versus a micro?
Yeah, right now, I think you are talking about variations across the country. Because like in California, where all our wrap comes from, we were so worried way back when of rutting, that we had all the old AR grades, that our asphalt, it tends to be pretty hard unless it's pretty fresh. The residual asphalt. But we definitely do look at like penetration on the residual asphalt. It's not, seems, at least we have not seen it been as big as a function on the slurries and micros, but we do find it in chip. because as much as we try to get everybody to reduce the application rate of the chip oil, because when you put on the traffic on it, it starts softening up on it. But we find it's more an issue of, you know, like hardness, we don't care on the chip at all, as long as it does it. But if we get some softer asphalt, so we do check penetration, we want to make sure that we let that know for the customer who's applying it. You're gonna use a lower binder application rate.
Gotcha.
That goes along with our experience as well. You know, the softer the asphalt is, the lower the shot rate you're going to want to use. Or at least that's like I said, that's what we've seen.
Okay. Very good. Well, I know we're approaching our scheduled end. See, Tony's about to drop off. Any closing comments, Morgan or Jason, panel members, Tom?
No, I think this was great. Thanks for doing it, Greg, and getting, you know, the team together to talk about their different aspects of the project. Yeah, it'll be good to set this up. You know, I think a real similar format for I think there's a concluding webinar, right? Like a culminating webinar.
Yes. When we
it's
have the
published.
documents completed. Yep.
Yeah. No, I think this format would be real good for that. So, thanks.
Are there any areas where we need to dig differently? I mean, did you see any deficiencies in what we have proposed?
No, not really. I think my one comment to that perhaps would be, you know, for the public facing one, you know, anything we could do to make it, well, we're not really trying to show, we're not trying to really sell anything here, but just it would be interesting to have a poll beforehand that said, like, you know, what kind of things do you see as that would inhibit your agency's adoption of RAP use and preservation? And then maybe if you got any responses on that, maybe tailor a slide or two of the webinar to address those challenges. Yeah.
Okay.
Gaps or barriers Jason just put in the text box. Exactly.
Absolutely. Yes, we anticipate structuring the public facing webinar quite a bit differently, with more interactivity and less of me droning.
It was good droning though, Greg.
Well, I felt like we had a lot of information to get through, so
Yeah.
I appreciate that. We like your groaning. Okay.
Jason liked it. All right. No, we're good on this end.
Okay, great. Well, again, I appreciate your time coming in and feeding back to our work here. Don and Mike, I appreciate both you guys coming in for question and answers, and to back up the work we've done and clarify perhaps. So,
And Greg, do you have a way to, you know, you're recording this, so do you have a way of sending the recorded link out to all the folks who registered but didn't show up?
yes, I do.
Okay, that'd be great.
We'll do that.
Do that.
All right, we'll post it on YouTube.
Mhm.
Or would it be better on a SharePoint site, perhaps?
Yeah, either way. I'd
Okay.
I'd hate for it to trend too much on YouTube, right?
Right.
Might blow up your server or something. However that works. But thanks a lot. Greg. Appreciate it.
Right. Okay. Very good. Well, I look forward to our next meeting. I think looking at the calendar, we are on for November 13th. Will be our next regular progress meeting. I've got a request. Jason and I are going to be traveling on December 11th. I would be open to moving our regular meeting earlier by a couple of hours, if that would work for folks.
Yeah, just propose whatever you guys need to do.
Okay, great. Very good. All right.
Yep.
Thanks everyone for attending, and look forward to the next time.
Yeah, thanks a lot. Good job.
Thank you.
Thank you, everyone.